the random forest. As shown in this example, the random forest, white color forest, it looks like a forest because it usually combined with a lot of trees. For example, here we have tree 1, tree 2, tree 3, etc. A tree n. So with all the trees, each of the tree may be trained and from the data, and then each of the tree has an output based on their tree structure giving an input. So each of them have a classification label. If that's a classification problem, based on all the output from all the trees, there's a different kind of voting mechanism. For example, here it's do the majority voting. After voting, we get the final class, and that is why we call it random forest. So mostly it looks like a forest, because usually there are a decision tree behind that. The random forest is an ensemble learning method for classification, regression, or maybe other tasks. So it's usually operated by constructing multiple decision trees at the training time. During the classification, each tree votes, and the most popular class is returned. The pros of the random forest, they have less overfitting, because from the data-wise, usually when we train the random forest, we do a lot of sampling, and then it constructs different type of trees. Each tree are different. Thus, the output always be different because the data sampling phase and the tree, they are different. So it's less chance to get overfitting. It works well for both categorical and continuous variable. That's mostly benefited from the decision tree behind the random forest, because the decision tree itself can handle the different variables. Random forest is handling the missing value quite well, and it is quite robust to the outliers as well. One interesting feature for the random forest is there's no feature scaling required. What that means is for each of features, like feature 1, the value range is like from 0 to 1. Then variable 2, they have the value range from 0 to 100. When we try to train the random forest, we do not need actually normalize all the two features, the all to 0 to 1. We do not need it, because we already use a rule-based approach. So instead of distance calculation, that's also attributed from the decision tree behind the random forest. It handling non-linear parameter efficiently. So non-linear parameters do not affect the performance of random forest, unlike the curve-based algorithm. So there is a high non-linear between the independent variable. Random forest may output as compared to other curve-based algorithms. So, but actually here we do not need to worry about the non-linear parameters. There are some cons. First is it is quite complex. Thus, because we actually create a lot of trees, not like one single decision tree, we have create like 100 trees. So that causes complexity, and also we need a longer time to do the training. And also the accuracy maybe is lower than the gradient both tree. There are usually two methods to create a random forest. One is called forest RI. It's called random input selection. It randomly select at each node the F attribute as candidates for the split at the node. The CRT method is used to grow trees to maximum size. There's another one called forest RC, that means random linear combination. So it creates new attributes that are a linear combination of the existing features. So it reduces the correlation between the individual classifier. The key theory behind the random forest is bagging. So how bagging works is the training algorithm for random forest. So apply the general technology of bootstrapping or bagging to the tree learners. So given training set X and the response is Y, the bagging repeatedly select a random sample with replacement of the training set and feed traits to these samples. For example, if B equals 1 to 3 to B, the samples with replacement will do the n training examples from X and Y. We call it XB, YB. The B means bagging. Then we train a classification or regression tree FB on XB and YB. The FB actually means the regression tree or classification tree. That means a decision tree early. After training, prediction for nth example X can be made by averaging the prediction from all the individual regression tree the X bar, or by taking the majority vote in the case of a classification tree. So yeah, this is how the bagging works behind the random forest. In sklearn, we also can find those two different methods. One method we call random forest classifier, another random forest regressor. This works well. I do not need to re-implement everything. And let me show another. This is a random forest demo. This problem looks simple, like this is a 2D dimension map. There are a few samples, like the red is one class, the green is another class. So we want to train a random forest model to do the classification. So the interesting things, of course, we want to decide how many traits you want to use. Like random forest is grow from traits. How many traits you want to use? If we turn the trait to 1, we only use one trait. So there are possibly some kind of you can see this is something like overfitting, because we train a random forest, actually a decision tree model, which is try to fit the data, and you can see the result looks really weird. It's not quite smooth. If we increase the trace, you can see the result looks a little bit more smoothly. If we increase the tree to, for example, here it's around 100. So you can see the decision tree random forest result looks a little bit blurring. That is the result actually with the voting. I mean the result from different trees. And it eventually converge a little bit to a reasonable and smooth decision tree style division. So now it looks much better. It looks more beautiful. Um, yeah, this is the example about the decision tree UI, how it looks like, how that works. Thank you.